I would like to introduce you to what our technology can do for the community of Canberra. First of all, we looked at the feasibility data collected over the past years, and we made a small simulation. We looked at the material that today goes to the landfill, and we analyzed what would happen if it was actually being sent to our facility today. The result is the following, that the landfilling level would not be almost 30%, it would be below 10% today. So this is the potential that our technology brings in. We deal with the waste that nobody wants. We deal with the waste that is mixed. We deal with the waste that doesn't have any market value and is really, really difficult to sort. Then what actually can we treat? We estimate from the projection that there would be about 290,000 tons of waste our technology is suitable for, and these are the waste streams that actually today are being landfilled. So we're not coming in to take away the material that someone is already dealing with and does it properly. We're looking at the material that actually no one wants. And of that material, there seems to be 300,000 tons of that expected around 2020. So what will be the result of us processing this material? Well, if we assume that the morphology of waste is similar to what is the case in the city of Warsaw in Poland, this would be the scenario. We would be basically recycling more than half of the material. Some of it would be evaporating, only 4% would be going to the landfill, and 25% would be used as refuse-derived fuel. So I also want to mention that the waste morphology for Canberra seems actually to be richer than the waste morphology for Warsaw region. So the part of resources, plastic, metals, aluminium, glass, cellulose, paper, would actually be greater, and the part of biomass and RDF would be smaller. Then also there are things that are dependent on local legislation, like aggregate. If we take out a fraction that is mineral and that can be used for technical purposes for road building, can we do that in Australia? Can clean material that came from municipal solid waste, can it be used as a construction material? So in comparison to what's happening in Warsaw, I would say that the biomass, we would actually have it about the same amount. Glass, we would probably have more, because we've seen that about 20,000 tons of glass is being collected today. We can take this glass, clean it, and make it a quality product. Then, for all the other materials, we would find approximately similar amounts as in the case of Warsaw, most probably. Then refuse-derived fuel. What would actually be happening with it? Well, actually, it seems that in the case of Canberra, the most rational way to go about the two main fractions of the material we prepare, biomass and RDF, would be like this. RDF, we would like to use it as a fuel in cement kilns. This is commonly done in Europe, where we create high calorific value material from municipal solid waste that also has very little chlorine, sulfur, and heavy metals in it. And we use it instead of coal. this is justified because we're using something that's a waste and we're putting it in place where today we're using most commonly coal in cement kilns. This is the way for this part to actually decrease our dependence on fossil fuels. Then the biomass. Biomass is a renewable energy source. What has happened in our process is that all the food waste and paper ended up in the biomass. So we take this material and it has diverse potential uses. But in case of Canberra, it would make sense to set up a biomass fuel combined heat and power plant and use this biomass there. So why does this make sense? Imagine this. If we have 300,000 tons per year of waste going to our advanced recycling facility, then the material that we would create that would be enough to supply 100,000 tons per year combined heat and power plant. This is enough actually to do this, to send the biomass, all the biomass, to the combined heat and power plant, and then the heat would be used for our process, for the Bioelektra process. This makes sense because not only what we're incinerating is just a safe fuel, it's a biomass that by European standards fulfills the norm for soil enhancers, and it can be used instead of agricultural biomass for incineration. But also, we would not only produce electricity out of it that we would sell to the grid, we would also use all the heat. And that's a very, very effective process that further decreases our carbon impact, carbon footprint of this combined facility. The Bioelektra technology has another pro. It's a possibility to simplify the collection of waste. Basically, Bioelektra's technology is fine with one bin. However, what we're pointing out is that cardboard, paper, and textiles, for environmental and effectiveness reasons, should be taken out to a separate bin. However, metals, plastics, glass, from the perspective of our technology, can go to one bin. So what we bring in is also an option, it's not obligatory, to actually create less rules of segregation at source. And we believe that the less rules, the more effective the system is. So it's not compulsory, but it creates an opportunity to adjust the waste collection system to make it more effective. The system that exists now, is in place, seems to be effective, and it wouldn't be my natural desire to actually change it right away. But it would require further analysis if it makes more sense to still sort out plastics, still to sort out glass, or maybe put it to one bin and send it to Bioelektra facility where it will be recycled. So, to sum up, the technology we bring in, the idea behind that we bring in to Canberra is to set up our technology instead of the landfill, almost, or let's say precede the landfill with this technology. Thus, that would decrease the amount of waste that actually reaches the landfill by a very significant number. All in all, allowing for going below 10% of landfilling within the next 2 years. Then the thing that can be done is also producing electricity, but just from the renewable fraction. And the choice of doing so would not be a fermentation, but would be incineration. And we would incinerate the material, the biomass, and use the heat to actually supply our own needs of thermal energy.